I haven't got any fancy recording equipment, so I'm just going to use a standard phone recorder, video camera, and my MacBook, and then rely on some software later on to edit the audio and take out any indiscrepancies that I don't want in the audio. Okay, so I've got all my sound samples now. The next thing to do is clean them up, because I've used a phone and not very good equipment to record them, so there's going to be a lot of wind noise and things that I don't want in there. So before I manipulate them, start time stretching them and everything else I need to do to them, I'm just going to clean them up in a program called Izotope. Okay, so here we've just got a saucepan noise that one of the saucepans is filled with water, and it sounds a bit like this. Now I'm just going to use this section just to so you can see all the harmonics going up. One thing we don't want is this bottom end frequency there. The main hit is about 300 Hertz upwards, so we're just going to cancel out everything below that frequency. Just doing a high pass filter. It's going to go from about 250, we say, a little bit lower. The next thing we need to do is, there's a lot of noise in there in between the hits, as you can see by this blue mass there. We're going to take that away. We use denoise. We adapt to the change in noise profiles. We just preview that. You can hear it's worked quite well, but it's not quite there yet, so we're just going to do a couple of iterations of this. And you can see every time it's making that background darker, but it's not affecting the main content that we want to keep. And compared to the rest, it looks like that, so it's what we got before and after. Okay, so I'm just going to get in a sliding door sample. Here we go, this is the sound of it. I'm just going to use this short section here. As you can see, there's a bird noise in there, so just zoom in. When the door's closing, you can hear a bird, which I think is this area there, so I'm just going to select that area and process a spectral repair on it. And as you can see, that bit just disappears. There's another bird in there, which I think is this area there. We'll do the same thing. Well, the birds are pretty much gone. The next thing is just a little bit of noise in there. So I'm just going to select this area from where I want it to begin. We'll denoise it. Gonna do one more iteration of that process. Okay, this is a wind sample I've recorded. I'm just going to use this section here. If we zoom in, we can see that the sound is quite dirty. There's vertical lines in here, which are these clicks that stand out. So what we're going to try and do is get rid of those. So we're just going to concentrate on this area. All the content is below 1500 Hertz. This is where the main wind noise is. The rest of it is just noise. So the first thing we can do is get rid of that. Next thing we need to do is, so it sounds like this. Okay, the next thing is these vertical lines. So the way to get rid of those is spectral repair. Now if we just concentrate on the areas that we want to get by using this, we can just create the box around the ones we want. So the first ones start just here. So we highlight them. Now the way spectral repair works is, because these are vertical lines, if we analyze the direction horizontally, those vertical lines are now going across the left to right grain, so the vertical lines will now be smoothed out rather than the horizontal wind noise that's there. And then as you can see, it's just taken away those vertical lines and it's not affected the horizontal lines. So we'll just follow that process. I'll just show you an example of if we did vertically. It doesn't do anything. So if we just carry on doing horizontal, and we could do it in big bulks, but it doesn't work as well. We did this. See? I just command Z that. It's better if we do it in small stages. I'm just going to turn the strength up a bit just to get these ones. And this is our resulting waveform.